For our second problem, we have something being thrown up into the air so that its distance above the ground is given as a function. And we want to type that function into our calculator, into the y1. So we push y, I should go back to the beginning. We're going to push y equals, and y equals gets us to that screen. And again, we're going to type in our function, and instead of a t, we're going to type the x, that's our independent variable button, and then plus 308 t, and again on our calculator's x. After how many seconds does it reach its maximum height? So again, we're given a function. This is objective 7, and objective 7 is that we can solve real-life problems using quadratic functions. This is a quadratic function, and the magic happens at the vertex. After how many seconds? And so if we look at if we were to graph this, we know that it's a quadratic function. The a is negative, so it's going to open down, and the value of the function is 0. 0 seconds, the projectile is at a height of 0, and it's going to go up and it's going to come down. That's what projectiles do. You shoot them up or hit them up into the air, throw them up into the air, and they reach a maximum height, and then they come back down, just like we know. So after how many seconds does it reach its maximum height? Well, I need to know that x value right there. So that's the guy I want to know. That x represents the number of seconds, that's time, and in seconds. And when we hit that time, the x-coordinate of the vertex, we have that many seconds until it reaches its maximum height. So if we graph this, zoom 6, always go back to zoom 6, because especially in the last problem, our window is out of control. Now, we don't know how far this is going, so let's try the trace feature again, and let's see how high this guy's going. It's going up 3 seconds. It's still going up, and you can do this fairly quickly. 1800, 1900, 2000, and again oh, here we go, we're coming back down. So it looks like 2100 or so we started coming back down. X16. So at the point of right around where the maximum value is, right around the vertex, x was about 15 or 16. And so I'm going to go ahead and increase the x all the way to 35. I'm going to leave the y min at -10. And the y max, let's put that at 2500. And again, let's make sure we change the x res to 3, and so we can get a good glimpse of our graph. And we second trace, we want to figure out the maximum value. We want to figure out the coordinates of the vertex. Hit enter after selecting number 4. Move the cursor to the left of the high point, then move the cursor to the right of the high point, and then get the cursor back into the middle somewhere. And we've got 14, 2156. So 14, 2156. Again, make sure you write that down, and then answer the question. After how many seconds does it reach its maximum height? Therefore, after 14 seconds. Like I said, it's going to be, the answer is going to be the x-coordinate of the vertex, because the x-coordinate represents time, and the y-coordinate represents height. It doesn't even say feet or whatever, but that's what that would mean. 14 seconds, it reaches its maximum height of 2156 feet or whatever.